you want to solve the simultaneous equation iz plus 2w equals to 1 and 4z plus 3 minus I w(x2) is equals to -6, giving z and w in the form of a plus bi, where a and b are real. Here, right, we solve the simultaneous, we can just do it as though like how we learned in the past. We can do it by substitution, we can do it by elimination. Right, so here, looking at the left and right hand side, we know, okay, intuitively you can see that this, it might be easier to create a substitute based on this. Right, so the next question is, do we want to make z the substitute, or do we want to make w the substitute? Alright, but if w is a substitute, right, if we make w the substitute, if we make w the sub, right, but if you look at the other equation, right, you can see it's w asterisk, so it's not very useful. However, let's say we think about making maybe z the sub, then that might be a viable option, right? So that's what I'm going to do. I'm going to look at equation 1, right, and I'm going to try making z the substitute. So how do I make z the sub? So z is now accompanied by an I. So probably what I can do is I can maybe multiply both sides by I. I can multiply by I on both sides, and what I get is I square. So I have a negative z plus 2iw equals to I, right? And from here, if I want to make z the subject, 2iw minus I equals to z, and you can see now z is now my substitute. This is equation 1. Okay, and next I want to have 4z plus 3 minus I can substitute this into equation 2 maybe, and I have 4 z will be 2iw minus I plus 3 minus I w asterisk equals to -6. Okay, and from here to go to the next step, probably I may need to break w down into 2 parts. Okay, so I'm going to call w, maybe I let w equals to x plus iy. Okay, so if w is equals to x plus iy, similarly w asterisk will be equals to x minus iy. Okay, then iz 4 of okay, then from here, right, looking at this form, alright, I will have very quickly, if I substitute in, I will have 4. Remember the earlier equation, I have 2iw minus I plus 3 minus I w asterisk equals to -6. If I sub in, I'll just 4 2i. So 4 or 2i probably is okay. Let me simplify this, right? If I can simplify, this is 8iw minus 4i plus 3w asterisk minus iw asterisk equals to -6, and substituting 8i x plus iy minus 4i plus 3x minus iy minus ix minus iy equals to -6, and I have 8ix plus 8i square, so it's probably minus 8 minus 8y, and minus 4i plus 3x minus I of 3y minus ix plus I square y, so it's like minus y equals to -6. Okay, and quickly, grouping all my real part together, all my imaginary part together, okay, hope quickly you are able to obtain negative, the real part is just -8y, right, plus 3x minus y, and the imaginary part, if I put 8i, -4, -3, so it's 8x minus x minus 3y, and this is equals to -6. And if I bring this 4i over, let's say it's -6 plus 4i. Okay, and from here what I can do is I now compare. So I compare the real part and the imaginary part. So if I compare from here, say if I compare from here, right, so -8y minus 1, -9y plus 3x right? This is equals to negative 6, correct? This is the real part. If I compare the imaginary part, 8x minus x, so 7x minus 3y, 7x minus 3y should be equals to 4. Okay, so all I need to do is I just solve simultaneously. I just solve. Okay, I hope you can do this by yourself. I'm not going to show you. And then you should get x equals to 1, y equals to 1. You should get x equals to 1, y equals to 1. So therefore, since w equals to x plus iy, x equals to 1, right? X plus iy. X equals to 1, I equals to 1 plus I. That's for w. For z, right? Going back to earlier question, we know that iz plus 2w equals to 1. Sorry, we have earlier on we can use z as a substitute, remember? Z equals to 2i w minus I. So z is equals to 2i 1 plus I minus I. Okay, simplify this. You're just going to get negative 2 plus I. And that is for z.